Hey there, this is Chris Hundhausen with a vlog on Agentic AI. I'm using the Copilot Agentic interface to work on a large code base, 90,000, 100,000 K lines, 6 million lines with library dependencies, a MERN stack application. And in this video, I want to show you how Agentic AI can raise the level of dialogue from low-level coding to higher-level architectural decisions, and how it can help a programmer who's considering design trade-offs think through these trade-offs clearly. So rather than having to do a lot of research on an unfamiliar code base, I know this code base fairly well, but a lot of the features I'm working with right now were written by my students and may not follow excellent architectural patterns all the time. So I'm kind of trying to digest some of the pieces of this code base on the fly as I'm trying to modify the code base. So the case study that I'm exploring in this video is this tournament wizard. So I'm working through a user interface. Let me show you this. So this is I'm going to cancel changes and exit. So this is a tournament. It's a wizard to create and edit a tournament. So here's a tournament, and I can click on edit. And then we've got these wizard steps that walk us through different phases of the tournament's design, ranging from the basic info to registration and payment, to color theme, to courses, to divisions. And the question that I'm raising in this agentic conversation with Copilot is, I was debugging an issue where the tournament dates were not sticking on save, and we worked out why that was, and I say, hooray, the registration and withdrawal dates for the tournament do now save properly. I was going to ask, though, if the wizard state is the single source of truth, we could avoid a round-trip API call by just retaining the wizard state data in the wizard until the user switches to a new tournament, right? We shouldn't need to call the API to get the data from the server after a save, should we? So what's at stake here is the tournament wizard. I redesigned, my student used a lot of use effects to update, and that caused a lot of asynchronous problems, let's put it that way, with the updating. And so I said, let's use the classic controlled component approach that is emphasized in a lot of React literature. So the React controlled component says there's a single state, and essentially whenever you edit an input field, it immediately synchronizes with that state. So there's a single source of truth that is synchronized at all times with the user interface. So think about the state as the model and the user interface as the view. And the view is just reacting to the model. So that's kind of where React gets its name. So I redesigned the wizard with this agentic AI to use a controlled component architecture. But there's still this, and I made some clever optimization. So tournament dates, for example, this is the start date of the tournament. Basically, once you have the start date of the tournament, all other dates can be stored as offsets from that start date. So this is essentially tournament start date +1. So these are integer offsets. The registration window can be a negative offset from the tournament start date. So this is basically 5 weeks before to the start date of the tournament. And then allow withdrawal to can also be an offset. So I said, let's use integer offsets so that we get instant updates of the dates based on those offset values. Every time a date changes, we just set the offset and then recalculate the date using a simple math date arithmetic. And so that also applies for division round dates. So there's a tournament can have multiple divisions, each of which can have multiple rounds on different days of the tournament. And so these are all offsets as well. So what happens then is we have an optimized kind of UI state that uses offsets. And then there's the original, what my student used was what we called the active tournament object, which is also in the we're using Redux. So we have in the slice here, we have essentially now two objects. We have the tournament wizard state and we have the active tournament state. And the active tournament state has actual dates instead of offsets. It also has a little bit different information that is needed by other parts of the app to do their work. And so what I asked the agent to do is help me think through this. Do we actually need to maintain these two different objects in our state, or can we go with one? And one of the lessons I've learned in using Agentic AI is you've got to make a lot of commits, because the agent can go off in a direction and break the code. You got to be able to revert, and so that's a lesson. So there's this keep button here. Every time it makes a change, you got to hit keep, because otherwise you get these synchronicity problems in the Visual Studio Code. And then you've got to do an update. When you've got a working version of the code, make a commit. So that's just my 2 cents on that. So the first observation I made is there's no reason to call the API fetch endpoint after a save, because we already have the data. And the agent agreed, yeah, that was stupid. We don't need to do that. And so with our new architecture where wizard state is a single source of truth, we have a few options. We can keep active tournament updates for backward compatibility. So it has this notion that the legacy code needs the active tournament for other reasons. We can remove it entirely, or we can update it only when necessary, like in non-wizard contexts. And so it gives me kind of pros and cons of each. And again, this is kind of active reflection. I'm an active reflective practitioner. It's helping me think through the design choices here. So it walks through explanations of each of these and how they might be implemented. And I come back and say, yeah, and then it actually goes and tries to make one of the changes. And I say, I hit the pause button. I say, there you go again, making changes before discussing them with me. Lay out the options and then we'll discuss and proceed with changes. You got to really bang on the GenAI not to make changes without discussion, especially if you want to do so conscientiously. So it gives you the current situation analysis and optimization approaches, and then some discussion questions. Isn't this cool? It's like I'm discussing architectural issues with the AI. And if I were doing this on my own, I would probably be thinking about this, but probably not so in such a structured way. I wouldn't have this could work with a conversational, like if you're doing pair programming, this could work where you have this kind of reflection on architectural decisions. And so it gives me some questions that I might use to guide my architectural decisions. And then I say, okay, let's step back even further. Help me understand this architecture. Because again, I wasn't involved in writing this. Is wizard state not a Redux object? And so it goes on to explain that there's actually two objects in the Redux store. There's an active tournament, which is kind of this legacy object that has actual dates. And then there's an offset-based format for the wizard. And okay, so that helps me. And then I say, no, we don't need the round trip call. They say, absolutely right, you don't. And then I say, how are we doing the API call? Are we using this kind of other format called active tournament, and then using active tournament to make the API call? And they say, no, we're not doing that now, but that's a great idea, so that we kind of do the synchronization with active tournament when we're doing a save. And that active tournament can then be a fallback if we don't save the wizard data. So they actually point out we're using a temporary object for saving, which is stupid. We should be using this Redux object for the save. and then I say, if it's true that other parts of the app need access to tournament dates that aren't offsets, it would make sense to keep these around. But then the flow should be to convert the wizard data to active tournament and then save to API, right? Absolutely right. So here's the correct flow versus the current flow. So we're making changes to this flow. And then I say, can you make the case that we should continue to maintain both wizard state and active tournament objects, which seem largely redundant except for data formatting? So then here's the pros and cons of each. I mean, I'd like to see where a conscientious software developer is really thinking through architectural decisions on a day-to-day basis with this level of detail. This tool is prompting me to reflect. It's a form of metacognition that's critical to being an active practitioner, a reflective practitioner, and a good practitioner. I'm thinking through things with more detail and scrutinizing design choices with more awareness. And I would argue that's a good thing. That's going to make us better developers. So here's the case for dual objects and the alternative, and there's a hybrid approach. Conclusion, the dual approach is justified because they serve different architectural layers. But then I point out, well, if it's just a matter of the dates being offsets versus real dates, the date transformations are O1 operations. So we shouldn't really worry about performance as one of the trade-offs because we have an O1 transformation from an offset to a date. You're absolutely right. So then what I'm trying to push on why shouldn't we just have one object? Simplicity, single source, or explicit boundaries. So what I need to really understand is there any reason, or what are the differences really between the legacy object and the wizard state single source of truth object for the wizard operations with the offset dates, date offsets? How is active tournament object used outside of the current tournament? And so it does this thorough code search. It would take me hours to do this. Not hours, probably an hour maybe. It does it in a matter of seconds, comes back and says, analysis, legacy, active tournament usage, wizard state versus wizard state, single source of truth. Key finding, active tournament serves real non-wizard functionality. And so it's showing that the core display logic on the tournament detail page relies on, a lot of the business logic relies on some of the fields in this active tournament object that are not in the tournament wizard. The tournament wizard is really dialed in for the UI, but there's other kind of calculated stuff that other parts of the app rely on. And so there's different use cases for each of these objects. And so what I really wanted to know then is, how redundant are these two objects? Let's get down to the nitty gritty. And it does this analysis again, and it shows me kind of each object and how they differ. And then we get this, look at this table here. So it gives me the high redundancy, medium redundancy, and low redundancy portions of these objects. I thought there was a table. Here it is. So redundancy level, wizard state and API metadata have 0% overlap. One's wizard specific, one's API specific. Conclusion, there's about 70% overlap, but 30% unique functionality. That's really interesting. So the question, if you really wanted to optimize this, you could pool together that 70% redundancy in one object, and then you could have, for that 30% difference, you could have two different objects. But I think this really convinced me, this table, that having two objects is going to be the way to go. And as long as we use that second object, the active tournament, we save the data, we update that on a save, so that becomes the source of truth to the rest of the app whenever data is saved. And when it's not saved, we can use that object to refresh the tournament in the case that the user cancels. So we save the round trip API call in either case. So we get the best of both worlds. We get efficiency by removing redundant API calls, and we get optimization based on the purpose. For wizard UI actions, we've got the tournament wizard state dialed in for that purpose, and for other application logic, we've got this other object. So in summary, GenAI can help developers become better reflective practitioners, think through coding choices at a high level of abstraction. Remember, this is code that I didn't write originally. I understand the general architecture. I'm an expert on React programming. I understand Redux. So I understand kind of the implementation abstraction. So I can talk at that level of abstraction without having to reason about the specific lines of code. That's what the GenAI is doing for me. It's allowing me to think through these things at a higher level of abstraction where humans, I would argue, are better. We're just better at thinking through things at these higher levels and not getting buried in the weeds. And so you could imagine that in a pedagogical context where we're teaching students these skills, that we can have them leverage the GenAI to do research projects on a code base, come back, if they ask the right questions, they can get the right data like this table I'm showing you to make good decisions. But they have to understand, they have to have some knowledge of programming abstractions, not low-level coding skills, but programming abstractions. They have to understand architectural patterns like using controlled components versus using use effects. So they need to have kind of that vocabulary at the kind of raised up in abstraction from traditional computer science. But I will argue that pedagogically, if we teach them those higher level abstractions, that is going to accelerate the learning process and get them up and productive and maybe even increase their interest in software development because they don't have to burden themselves with the low level syntax of programming languages. They can think about things at higher levels. And that, I think, will be intrinsically motivating. Okay, till next time, folks. Hope you enjoyed this vlog.